Bismillahirrahmanirrahim. Welcome to the lecture 5 User Authentication Part 1. So in this lecture we are going to see the basics of authentication and types of authentication, and also we are going to discuss some authentication algorithms. So the user authentication is a fundamental security building block, and it's a basis of access control and user accountability. It's a process of verifying identity claimed by or for a system entity. So any user who has to access any resource, the user has to be authenticated. Okay, so when you want to access the SIS or college network, okay, SIS college domain, okay, or any website like Facebook, the user has to be authenticated. So to do the authentication, two things are needed. So two things are needed. One is identification, our ID, and the second one is verifying the ID. So what is the identification? Our username, password, biometric details. These are the identification. And verifying the identification, so that is connecting the associating, that is called binding, associating the identity with any user or any system, okay, is called verification, authentication. So the authentication has two components, identification and verification. So some algorithms are used to verify the identity of a person. So the algorithms will associate the identity with some person or some computer, some system. That is called verification. So the authentication has two steps. One is identification and another one is verification. So these are the different types of authentications, like password, something what we know, what we remember in our mind, like password, pin number. Okay, if we forget the password or the pin number, okay, it would be difficult for us to log in. Then something we possess, like keys, the keys which are created using symmetric encryption algorithms, asymmetric encryption algorithms, and token and smart cards. And then the third one is something what we are is, like it is already inbuilt in our body, like fingerprint, eye, retina. So iris, there is another type of eye scan, iris, 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 retina. Okay, then something what we do, like signature, voice. Okay, so these are the different types of authentications. So these authentications sorry, these kind of identities, these are the different kind of identities which are authenticated, okay, can be used alone or it can be used in combination. So when we use more than one, okay, then it would enhance the security instead of relying on simply using a single identity based authentication. If we go for multiple identity based authentication, then the security would be improved, enhanced. So just now in the beginning I told we have the identity. The identity should be verified with a user or a computer using some algorithms, some protocols. Protocols are built using some algorithms and they are implemented using some programming languages. Clear? So authentication protocols are necessary to perform the authentication, verify the identity of a person or a computer. So these authentication programs they verify the identity of systems or users, and they allow the systems to exchange session keys, because once the authentication is finished, then what happens, okay, let's say you connect with the okay, you are the client. So when you connect with the Facebook or with the SIS, so authentication is performed. Finally, both the client, the user, and the server, they generate a symmetric session key. Okay, so some symmetric session key, and both they would share the same key, so that any message which is transmitted across the network between the client and the server, it would be encrypted using the symmetric session key. Whatever message transmitted between these two systems, it is encrypted using the symmetric session key. Okay, so this happens after the authentication is done. Similarly, okay, you log in into the domain controller. Okay, you log in. Once the authentication is successful, okay, so you are encrypted. So after login, you want to access, okay, some web application inside the organization domain, inside the organization. Okay, so all the communication between you and this are encrypted using a session key. So all the communication between you and the domain controller is authenticated, okay, after authentication. So the authentication protocol may be classified into, okay, like A, B. So A is authenticated to B. A's identity is verified to B. Okay, so this is called one way. A's identity is verified by the B. So B is sure that B has verified the identity of A, but whereas the B's identity is not verified to A, so the reverse is not happening. So in another situation, let's say A and B communicates, A identity is verified to B and B's identity is verified to A. Okay, so this is two-way. So two-way authentication. Okay. So I give one example, let's say. So now let's say the user okay, is connecting to Facebook. So when the user send a request, the Facebook would send its certificate. So the certificate is used by the Facebook to prove its identity to the client. So now the server identity is verified to the client, is proved to the client. Now what about client identity to the Facebook? Is it verified? So now once the Facebook shows its certificate to prove its identity, okay, then you have login page. So here you have the username, here you have the password, and then here you have the password. So you enter the username, you enter the password. Now you send these details, these username and passwords are authenticated by the Facebook server. So this is example of two-way authentication. Okay. So there are some issues in the authentication protocols. One is called confidentiality, another one is called timeliness. So what is confidentiality? The session key which is used has to be protected. There should be confidentiality to the session keys. So you would have seen in the previous chapter in which A and B, they obtain the session key from the KDC protocol, key distribution center. Okay, so there the issue is the session key has to be properly shared between two systems. Next one is there should not be any delay in the data transmission. Maybe attackers, they capture the packet and they send the packet to the target after some time. That is called replay attack. Capture the message and after some time they send the message. So how you can detect and prevent? Check the time of the message. If the time of the message, for each message there should be a time limit. After that time limit, the message should be expired. It should not be valid. It should be considered as invalid. Okay, so in any message when you send between systems, the time should be specified, time stamp, and also you have to specify how much time this message is valid. So any attacker is capturing the message and sending very late to the target machine as a replay attack. This can be detected used by checking the timestamp and also the validity, how much time this is valid. Based on that you can detect and you can discard, reject the message. So thereby you can prevent against the replay attack. So what is a replay attack? A replay attack occurs when a cyber criminal eavesdrops, sniffs on a secure network communication. He would intercept the message, capture the message, and then fraudulently resend the message to the target. So you can see this user is sending a message to the server. The message is captured by the attacker and the attacker would send the message after some time to the server. Okay. Let's say this is the client, this is the server. So some message is transmitted by the client. That message, okay, is captured by the attacker, and then he send the message, okay, to the server target machine. So here what happens is the attacker is able to capture the message, he can modify the message, he can compromise the confidentiality of the message, and he can use the same message to log in into the server after some time. Clear? So if the message has timestamp, okay, so and the timestamp say, and also it has time limit, how much time this message is valid. Let's say it is valid for 60 seconds. So this message starts, okay, at 9 a.m. timestamp, and let's say this attacker is sending at let's say 9:10 a.m. So using the timestamp, the server can reject the message because the timestamp says 9 a.m. this message was created and its validity is only for 60 seconds. So somebody is using this message even after the the time limit has expired. So the timestamp, using the timestamp is a very useful mechanism against the replay attack. So now you are seeing here what is a replay attack. Remember the diagram also. So how you can stop the replay attack, how you can prevent the replay attack, what are the countermeasures against the replay attack? Let's discuss the two things. These are practically can be achieved. One is using the timestamp, okay, what time this message was created and how much time this message is valid in the network. So inshallah in the class we will see, when we discuss the Kerberos protocol, I will show you in the Windows server group policy settings. If you go to Kerberos, because the Kerberos protocol has the mechanism to protect against the replay attack, it uses the timestamp, okay, and also validity of time, how much time this message should be valid. All these things can be configured there. The next one is, students, using the nonce value. Already I have explained about the nonce. You remember the KDC. In the KDC, you have the KDC server, you have the system A, you have the system B. So when system A send its ID of B, requesting for a session key, it will send the nonce value N1. Okay, so the nonce value, basically the idea of the nonce is to protect against the replay attack. So finally, let's say the B will send encrypt using the session key some nonce, and this will reply encrypt using session key f of n1. So n1, let's say is 10, let's say f of n1, let's say 2 into 10, some function, some calculations. Okay, so this is called we consider this as challenge response using nonce. Challenge response using nonce. So students, the important two mechanisms which could be used to protect against the replay attacks, or practically which could be achieved, are timestamps and the usage challenge response mechanism using the nonce value. So some examples, let us discuss some example about the replay attack. Now let's say you enter your credentials to log in into a website. You want to log in into a website. So you enter a username and password and click the submit button. So your browser will send the data to the credentials to the server. So somebody in the middle, attacker, they capture the packet. A malicious intruder eavesdrops on your network communication using packet sniffer like Wireshark. Okay, so now the intruder, the attacker, has the data, your credentials, and the attacker capture your credentials, but you and the server doesn't know that something is going on in the middle. Now the intruder, after some time, he will use the captured credentials, captured data, and he will try to log in into the server, and the server would authenticate the attacker, and the attacker can access the resources in the server. He can access the files, he can misuse the data. This is called replay attack. So this is explained using the diagram. So already I have explained you what is one-way versus two-way authentication. In one-way authentication, only one system, one person or one computer verifies the identity of another person or another computer. In mutual authentication, and any two-way authentication, both the entities A and B are authenticated to each other. So I have explained you mutual authentication example. Every time you log in onto a server, you are mutually authenticating. Example, when you log in into the SIS, when you log in into the Blackboard, when you log in into the Facebook, there is a mutual authentication. Two authentication is going on. Your browser trusts the remote server certificate, and you can see the lock here. So once the certificate is valid, you can see the lock without any error message. So it means that your the target system, the server is authenticated, certificate is authenticated. Then you are prompted to enter your username and password. So now the server is asking your identity. It is asking you to verify your identity. Okay, username and password. Clear? So this is called mutual authentication. Friends, these are some of the authentication protocols like Kerberos, Radius, TACAX, EAP, Extensible Authentication Protocol, CHAP, Challenge Handshake Authentication Protocol, PAP, Password Authentication Protocol, Network LAN Manager. So in our domain, okay, our college domain, okay, when you have a domain and you have many many computers connected to a domain, then which protocol is used? Kerberos is used. And in large organizations, to improve, to strengthen the authentication process, enhance the authentication process, if you want more security, then they use the Radius along with the domain, along with the domain controller. They use the Radius server or TACAX server for authentication. So you have, let's say we don't have a domain, then the authentication is done using NTLM, Network LAN Manager, in the Windows systems. Clear? So this is the structure of the Kerberos protocol, which is based on the KDC. The Kerberos protocol is used in the domain network, and it is used to authenticate the client systems. So in the Kerberos protocol, students, when you do the authentication, after doing the authentication, there is a provision that you can access any service without further authentication. For example, let's say you log in into the college domain. So after the login into the college domain, if you want, there is no need to log in into other services like advising system or SIS. So one login, because for example, let's say you are logging into the Google, then without any further login necessity, you can access the YouTube, right? So that is how the Kerberos protocol works. Okay. So there is this you will study in lecture number 6 in detail, so I am not going into detail now. Now let's revisit the Needham-Schroeder algorithm, which we have discussed in the chapter number 4. Okay, so we have the KDC, we have the A, we have the B. So A, okay, is sending its ID, then it wants a session key with B, then it is sending a nonce value. Okay, now what happens? This is first. So let's say now 2. So now this KDC will create some messages. Let's say M2. Okay, so this message is encrypted using the master key of KB. So it would contain the session key. Okay, so this session key is to B. It is encrypted using the master key of B, KB, and this session key can be used to communicate. It can be used by the B to communicate with only A. So this is the message 2. Then message 1 would contain it would contain the session key for A. So this could be used to communicate with the B. Okay, and also it will send the nonce. It will send the nonce back. So you can see session key to A. Okay, it is used to communicate with B, then nonce. Whatever nonce A send, it will come back. This is message 1. Now this message 1 and message 2 are combined. M is equal to encrypted, because this message 1 and message 2 is going to A. So it is encrypted using the master key of A, M1 concatenation M2. So now the KDC would send the M to A. Now what happens? A will send the M2 to the B. Okay, it will send the M2 to the B. So this is third, this is fourth. Okay, no, let's say this is second, this is second, this is third. This I don't want to give number. This is created by the KDC. So now so this will send encrypted using session key some nonce value, and then this system would send the reply, okay, by just converting this value into some other value. So this is how the Needham, Schroeder and Schroeder algorithm functions. So here the session key is shared between the A and B, but however you can see there is no timestamp. Nonce value, even though nonce value is used, but there is no timestamp. So you get a question here: does this scheme have any drawback? Is this scheme, does it have any drawback? Can any attack happen in this scheme? Yes, the replay attack is possible at step 3. So students, This is the step 3. So here this message can be captured by the attacker, and he can send this message to, sorry, this is not this, he can send replay, he can do replay attack, and he can communicate with the B like A. So he can do the replay attack, this place. So he can capture this message M2, okay, and he can do the replay attack. So how you can overcome this issue? So yes, there is an attack possible, that's called replay attack at step 3. So let's say if the attacker knows what is the session key, okay, so then he can capture the step 3, this message 2, and he can find what is the session key. Then after that he can compromise the security between A and B in further communication like 4 or 5. So what is the solution now? Solution is this. So in the step 2, please add timestamp T. Here timestamp T, add the timestamp T. So if you add the timestamp, then what happens? If the attacker is capturing the M2, then if the attacker is sending the message after some time to B, then if there is no proper timestamp, if there is no timestamp, sorry, if there is a timestamp and if there is a delay in the message, see, attacker is capturing the message but sending after some time, but in that message there is a T value. So the T value will tell the B whether this message is it a latest Jadid new message or old message. So if it is a old message, then the B will reject, thereby protecting itself from the replay attack. So the solution, please students, adding the T. So I give, I say that I give this algorithm and I ask you the question like this, and then you have to say there is a, yeah, of course there is a replay attack. How you can improve the security of this? By adding the timestamp, okay, at adding the timestamp at T at step 2 and step 3. So next, the final discussion is how this Needham-Schroeder algorithm can be used for one-way authentication. So there is an example given here, students. When you are sending an email to A, is sending an email to B. So A is getting the session key. Okay, so A has got the session key. You know this step A, step 1 and step 2 you know already. Clear? Now the A got the session key. Now what it is going to do? A is going to send a message. So you see, this message is the email. That email is encrypted using the session key KS, and then, okay, what it is doing? Okay, it is sending the session key to the E. Okay, let me do it again for you so that it will be easy for you. Let's say A, the KDC, B. So let's say A is telling KDC, I want session key to communicate with B. I want to send email. Okay, so you know what the KDC does. The KDC does this: M2 encrypted, KB, KS, ID, A. It creates this. Then it will create AM1. It is KS, understand, then ID B nonce, and M is equal to encrypt KA comma M1 and M2. So now it will send the M. Now let's say the A has the session key. Now A has the master key, A has the session key. Now B has the master key, but it doesn't have the session key. So it wants to send the message encrypted using the session key. So what it will do, students, what the A will do something here. Okay, what A will do, it will create an email message. So encrypt using the session key, email the message. It create an email. Okay, so it will send encrypted email. But when the B receives this, it cannot decrypt because it needs the session key. It doesn't have the session key. So what it will do, it will send the message M2, because the KDC sent the M. So inside the M you have the M2 and you have the M1, understand. So it will take the M1, A will take the M1 and read the session key, and then it will send the M2 here. So M2 is nothing but M2 contain the session key. It is encrypted using the master key of B. So when the M2 go to the B, it will decrypt using its master key and obtain the session key. Then after that it will decrypt the email using the session key. So if this process is successful, it proves that the B will identify that it has received the message from A successfully. Clear? So but the B is not authenticated to A, but A is authenticated to B. So this is one-way authentication. This approach guarantees that only the intended recipient of message will be able to read. Only the B can read the message. No other person can read the message, because the email is protected using the session key, and the session key is sent to the recipient, yani B, protected by the master key of B. It also provides a level of authentication. Okay, there is authentication. What is authentication? Sender authentication. So A is proved to B, but B is not proved to A. But there is no need. Why there is no need? Because it's email. And here also please understand, there is no necessity of sending email, because the email delivery could be delayed. If there is a delay, then if we use the timestamp, then the email might be rejected. So this is just to show the one-way authentication. Okay, so with that, this chapter is concluding. So we will continue the chapter 6 in the forthcoming class. Thank you very much.